I think it's going, isn't it?
Yeah.
Okay. Hey, kids, here's the deal. Things to remember from the past. We've talked a lot about triangles, especially if you were with me last year. We spent a lot of time talking about the sum of the measures on the inside of triangles. So what's the sum of interior angles on a triangle or inside? 180. Okay, you always know that angles are going to add up to what? 180. Okay, I want to show you something real quickly here. Big concept today is this. Here's a triangle. I'm going to draw a triangle for you. You ready?
Yep. Wow.
There it is.
Oh, I did not see that. Wow.
Tricked you, huh?
Don't like that.
Don't like that one as much?
I like that one.
Oh no, that's good. Nice.
Let's do this. I'm going to get rid of this one.
I don't like triangles, so...
Those are similar.
Okay, I'm going to do this for you. Suppose I tell you that this angle is 90 degrees. And I tell you that this angle down here is 90 degrees. And if I tell you that this angle right here is, I don't know, how about 40 degrees up here? And if I tell you that this angle is 40 degrees. How many pairs of angles are equal?
2. So it has to be 3.
Angle, angle, angle.
Well, wait a minute. I only see 2 angles up there that would match up.
But if you do 180 minus 30 minus 40.
So what you're saying is this. If I do the math, carry on with that, Jacob. Where are you going if I do the
You
math?
have to do 180 minus 130, so it would be 50.
So the sum of these 2 angles right here is 130, so that makes this 50, right?
Yep.
And if the sum of the angles here is 130 and subtracting it from 180, that makes this angle a what?
50.
Okay, here's the deal. In any triangle, listen to what I say. In any triangle, if you know 2 angles, then you know what?
3.
If you know 2 angles, you know 3, because you can find it. Okay? So what we're going to talk about then is this. Are those angles, are there 3 pairs of congruent angles up there?
Yes.
Is the size of that the same or is it different?
Different. That's what I'm
Okay, but if the angles all match up, what has to be true about the shape?
That's just
It's the same shape, making them what?
bigger.
Similar. Okay? So angles are always preserved in similar figures, but you can change the size of it. Again, this is 90 degrees, this is 90 degrees, but that's in a much larger triangle than this over here. That's okay. Angle measurements being preserved or staying the same tells us that these 2 figures are, what's this symbol stand for? Similar. I was thinking spring roller coasters. Okay. I want to go on a roller coaster. Okay, I like roller coasters. Okay, guys, 8.4. Proving triangles similar by what? Angle theorem. That's what that says. Okay. Question today. Michael, you ready, bud?
Yep.
Go ahead.
What can you conclude about 2 triangles when you know that 2 pairs of corresponding angles are congruent?
Okay, what that question is really saying, if you know 2 pairs are congruent, then you actually know that 3 pairs are congruent. We're going to talk about this, okay? Our goals today say the following. Use the angle similarity theorem, and then we'll look at some real-life problems related to this. So here we go, kids. Not too bad to do. You guys know what similar figures are from previous sections, but they're figures that are the same
Shape.
but different
Size.
size, okay? Same shape really kind of means same angles right here. So I'm going to put this down here as same angles. That might be a note that we have to add here today. So do that. The angles are going to stay the same. And then we've talked about similarity transformations. A similarity transformation is 1 or more rigid transformations, like a reflection, a rotation, or translation. And then you follow that up with what? You change the size. Okay? So we've talked about that before. All right, core concept today. Let's talk core concept. Here we go. We have the angle similarity theorem. And we've kind of talked about this already. The angle similarity theorem simply states this, kids. It states that if 2 angles of what? 1 triangle are congruent to 2 angles of another triangle, then
The 2 triangles are similar.
okay, if angle A is congruent to angle D. I'm not too worried about this here. So let me just do this real quickly. Let's draw a triangle. How about one like this? Okay. Okay, so if I tell you right here, if this angle right here is congruent to this angle right here, this angle right here, 2 arc marks here and 2 arc marks there, then what must be true about angle A and angle D? Okay, I'm going to get rid of the word if. All right, what's that mean about angle A and angle D? It's basically saying if you have 2 pairs of congruent angles, then you really have 3 pairs. Okay, so I'm telling you the bottom left angles are congruent, bottom right angles are congruent. If this is A and this is D, then they are also congruent. Okay, so what this really states right here then is this must be true if the first 2 pairs of angles are congruent. So really this says if you have 2 pairs of congruent angles, you really have 3. What theorem is that called again? Angle, similarity theorem. Okay, so if I can show in triangles that 2 pairs of angles are equal, then the triangles must be what? Again, listen to what I said. If in two triangles, if I can show that 2 pairs of angles are congruent, then they are. All right, so let's use that idea. Move on here. Okay. You guys ready for this? This is kind of hard to see. Let me blow this up a little bit. I can hardly read that. You guys, I'm going to have to look at some notes here.
I can't even read it.
Oh, I'll bet you can. If you can't read that, you need to get some glasses.
I'm supposed to wear glasses.
Are you really?
Yeah, but he's blind.
All right, let me look at my paper here, kids. Up there it says I have 2 triangles. It says determine whether, wow, that is pretty small, isn't it? Oh, yeah. I have my contacts in. Determine whether the triangles are similar. If they are, write a similarity statement and explain your reasoning. Okay? Holy cow, what have I done to you guys? Hang on, let me see if I can do something differently. Give me a second. Let me get you a better visual. Is that okay? Can you guys read that a little better? Hey, this angle down here at X, down here in this X, this is 21 degrees. So draw that in there. And this is 99 degrees. Okay, you guys got 99 degrees in at Z down there? So 21 and 99. At T up here in the bigger one, this is 61. And this R down here is 21 down there. Okay? Can you guys get those numbers written in there for me? So I'm going to go back to my notes. Blow this up here. This angle right here is how many degrees? Whoa. 21 degrees right there. This one was 99. You have a 21. And this is a 61.
I think they are. No, they're not.
Now, how many pairs are up there are congruent just with the given information? 2.
So you know the third.
Well, we can find the third in each one, right? Okay. I can start by saying angle X is congruent to angle what?
Use that R.
It's an R down there, yep. So angle X is congruent to angle R because they're both how many degrees, kids? 21 degrees. Gosh, the 61 and the 99 don't match, but could I find a third angle in each triangle? Okay, what's the third angle? This is S right here. Anybody know this angle S right here?
Well, you get 82, and then you have to subtract that from 180, so it would be 98.
98?
Oh my god, you know what?
That was in my head, but I think I did it right.
That's gotta be 98.
Do I have the right degree?
It's one off, man.
It's 98.
That's not. Are you
Yep, I'm
serious?
right. I'm right. So,
See you guys? Gosh, they're not similar.
That's not.
okay, so what's angle S up here? 98 degrees? What's this angle right here? What's angle Y?
Probably
That would be
60.
60 degrees.
This would be 60 degrees.
Oh, so no.
So are these similar or not?
No.
Okay. Triangle RST,
They're at what?
they look similar, is not
They're kind of similar.
But not with
We're
our
1
definition.
degree off.
not similar to, what's the name of the other triangle? XYZ?
You didn't quite hurt in his feelings.
I know. Because how many pairs of angles do we have congruent?
One.
Because only one pair is congruent. And we need at least how many?
2,
2. And if we have 2, then we would definitely have what?
3.
Okay, so triangle RST is not similar to triangle XYZ because,
There are not 2 angles.
okay, can I say because we only have,
Yeah, 1.
how many pairs of congruent angles here?
1.
We only have one pair of congruent angles. And we need what? And we need 2. Okay. Triangle RST is not going to be similar to triangle XYZ because we've only got one pair of congruent angles in there. And we need to have at least 2. So that's not happening here for us. Not happening.
Not in this house.
Not in this house. No way.
This is cool, so it couldn't happen.
All right, so let's look at the next one. This next one, does it show up a little better for you? I can actually kind of read the next one. You guys have all that written down up there? Okay, using the angle similarity theorem, it says show that triangle, I'm going to blow this up here one. Is that okay? Show that triangle QPR is similar to what? QT Parson. QTP.
Okay, well, this is going to be a little confusing.
Okay, this is actually not going to be bad. Let's first of all figure out. QPR is a triangle on the outside, right?
Oh, wait, I didn't see the box. The box doesn't show up.
Okay, you got QPR there, right? What's the other triangle we're talking about?
QTP.
QTP. Which is, I'm going to highlight in yellow here. Kind of right in here, isn't it? Ooh! Think about this. What's true about angle T and angle P down here for the two triangles?
What?
Okay, both are 90.
So
So,
it's a bisector.
well, think of it this way. Don't worry about bisectors, but isn't angle T the same as angle P down here being right angles?
Oh, so we have, no, we don't have to.
So listen to this right here. Angle T and, can you guys read that okay?
Yeah.
Angle P, both how many degrees? 90 degrees, right? So how many pairs of congruent angles do I have already? One pair. Now think about this. Is angle Q part of the small triangle?
Yes.
Is angle Q part of the big triangle?
Wow. So they're not similar. How do you write that?
Well, think about it. Isn't angle Q part of this big one on the outside that we're talking about? Wouldn't angle Q's angle be the same measure here as it would be in the small one? So angle Q is the same in how many of the triangles? Both of them, right?
How do you write that?
So
Angle Q is equal.
angle Q and angle Q, they're part of both triangles, right? They're part of both triangles, and they're what? They're equal. Guys, how many pairs of angles have you shown congruent so far? You shown that the two right angles are equal, right? And you know that angle Q is part of the small triangle, right? And you know that angle Q is part of the big triangle, right?
So there has to be 3, so there are.
So it is going to be what?
It's going to be similar. even
Watch
though
what I
we
do
don't know
here.
that.
Try and rotate this.
And then dilate it.
That's so beautiful.
What?
Oh my gosh, you can rotate it.
Like a potato chip, you bet. Oh, shoot.
Oh.
Oh, did you get that?
Yep. You make fun of me? You make fun of me?
I think he's bullying
Cowboy, you make fun of me, cowboy? Huh, cowboy, you make fun of me? Yeah, you guys, take a look at this. If you could kind of flip this over and then rotate it, wouldn't it be similar to this? Doesn't QTP kind of look like this? If I would, let me try to rotate this. I wish I could, we need a flip tool instead of a rotate tool. I'm going to flip this way. Watch what I do. Like my flip? Like my rotate?
I can
Yeah. Kind of the same triangle, isn't it?
Sure.
This is angle Q, matches here. There's the right angle, matches here. This angle would have to match that. So, what are you going to say, kids?
Angle Q.
Once I've shown two pairs of angles equal, I'm going to say that triangle QPR is similar to triangle what? QPT. And what's our reason?
They have two angles that are similar.
Yep. So what do you want to call this? Angle, angle, similarity theorem. Do. It's almost hot. We'll call it do ast math. Do ast math.
We shouldn't like spend
Do ast math.
You know that's a song.
Du hast. Du hast mich
Yeah.
by Rammstein.
It was on the radio one day.
It's good stuff, isn't it?
She actually played German.
Yeah.
Last example, kids. Let's roll. I like this example. Put a star by it. You're going to need to know how to do one of these. A flagpole. Cast say what? That is, at the same time, a boy who is 5 feet casts a shadow that is 51 inches long. How tall is the flagpole to the nearest what? Okay, you have to be careful on this, kids.
You gotta use the ratios.
You do have to use ratios, but let's talk about the flagpole. How is that measured? How is the shadow measured?
Inches.
Inches.
Oh, wow.
Now, careful on this.
I hate these people.
Convert it. 12.
Yeah, we have to be careful. It's probably a good idea to make sure all of our units are the...
Same.
Okay, so let's talk about this. I'm going to go ahead now. We also have to make some assumptions here. Hopefully, whoever put the flagpole in put it in so that it's what angle with the ground.
90.
Hopefully. Okay, so there's an assumption here. So let's make a picture.
What if they were a bad contract?
Well, it's possible. It happens.
This is disrespectful.
Like that?
Kind of like that. That guy didn't put the flagpole in very well. Okay, otherwise the wind blew it over. One of the two. Yeah, like the Leaning Tower of Pizza.
We still can't assume that's not.
Can't assume, but we're going to make it. Okay, so here's my flag.
That's at all the stars.
50.
So we need 13 stars.
Oh, you forgot the 50 stars. You can make 13. I'll give you that.
Yeah, this can just be the original flag.
Yeah.
That's all it is. Let's just do 1 star for
30.
What color
40.
are you doing them in?
50. Okay.
America.
Yeah. War Eagle.
Sitting on top of the flag.
Now we need to draw the boy.
Okay, so here's the dealio. How tall is this flag?
540 inches.
Okay, where'd you get 540 inches?
12 times. It was
Okay, I'm gonna convert everything to inches, kids. So this 45 feet right here, this 45 feet, this 45 feet right here is 500 and what? 540 inches, right? You would take 45 times 12. Do you agree with that, kids? Okay, and it casts a shadow. Okay, at the same time, there's a boy standing around here. Here's a little boy. Here's my little boy.
Shouldn't it be right next to the flagpole?
It doesn't matter.
I'll put him there. Yeah, let's do that. Here's my little boy. How tall is he?
51 inches. No.
How'd you get 51 inches?
It tells you.
Well, you got to be careful. It says at the same time, a boy who is what? 5 feet. Okay, 5 feet. How many inches would that be? What's 5 times 12, kids?
What angle was this?
62.
60 plus how many more inches? 5 feet 8 inches would be what?
Plus 8. 68.
So he's 68 inches tall, right?
Dang it.
You guys agree with that?
With the shadows.
He's got a little shadow down here he casts. It says the shadow's how long that he casts?
51 inches.
51 inches. Okay. They want to know how.
He's got a cute little baby triangle.
I don't understand
Oh,
how
I have
it's
this. I have this drawing incorrect. Okay.
Oh.
It says a school flagpole casts what?
Shadow.
Oh, the 45 shouldn't be here, but it should be where?
Right there.
Down here. So this whole length down here should be how much, kids?
455.
Okay, so let me clean this up. Let's get rid of the dimensions over here. Okay, how long is this in inches, kids? 540 inches? Okay, the question says, how tall is the...
Flagpole.
Flagpole. Well, we can use some simple cross multiplication.
Yep.
Well, 68.
So, what's x correspond to? What height does x correspond to, really?
The 68.
So I'm going to go x is to 68 as what?
5 as 40 is
As 540 is to 5.
Yeah, if we're going to set a ratio up, if I go x to 68 first, I've got to go big value to what first? Okay, so I'm going big height to small height,
Big height.
longer length to... Okay, so your ratio for this, what would it look like, kids? X over,
68.
that's the first ratio. Help me with the proportion. What's the other part of the proportion?
540 to 51.
51, you said? Okay, so the question says, how tall is a flagpole to the nearest foot? When I cross multiply and divide here originally, this is all going to be relative to what unit?
Inches.
This is how many inches when you're done? So x is,
Oh, then we gotta divide that by 12.
yep, this would be 720 inches. So to divide that by 12, that's would be
60 feet.
how many?
60.
Okay, so this in feet would be
60 foots.
60 foot.
Wow.
How do you guys feel about this?
I feel pretty solid.
Pretty good?
That was
Pretty okay?
I really wanna make the flag a little bit more.
Okay. Guys, we're going to do a quick quiz a little differently today. I'm going to stop the recording here.